Okay, we're now going to start looking at compounds that have 2 or even more chiral centers and see how to work with these. So for example, I have this disubstituted pentane molecule, and there's a chiral center here with a chlorine, the chiral center here with the alcohol. Now, as I have it drawn right here, the three-dimensionality isn't shown, so you don't know what particular stereoisomers I'm describing here. But let's systematically try to draw out the various stereoisomers. The first thing we can do is remember the rule 2 to the n, where n equals the number. For now, we're going to stick with chiral centers. We have 2 chiral centers, 2 to the 2 is 4. So that is the maximum number of stereoisomers. Now what I'm going to do is I'm going to draw this molecule. But remember, we can put the chlorine and the OH on dashes and wedges. So in our first one we're going to draw, let's put the chlorine on a wedge and the OH on a wedge. Alright, then the second option, what if we put them both as dashes? Okay, the third option, let's put the chlorine as a wedge, the OH as a dash, and then the fourth, the chlorine is a dash, and the OH is a wedge. I'm just going to give these letters. Okay, now if we compare what we have here, compounds A and B, you have both chiral centers inverted, going from one to the other. If all the chiral centers are switched, that means we have a pair of enantiomers. Right? And the same thing for C and D. In C, if this chiral center gets inverted and this chiral center gets inverted, we have another pair of enantiomers. So remember, in a pair of enantiomers, we have a pair of non-superimposable mirror images. And you can say in a pair of enantiomers, all the chiral centers are inverted. So just to give you kind of another review on this, we drew A's enantiomer by inverting all the chiral centers. But you could have also done it by drawing the mirror image. Here's A. Here's the mirror image of A. Which is compound B. So if I just give you kind of a point of reference, this carbon here, NB, if I flip this horizontally, here's my point of reference, flipping that over brings the OH over here to the right, but that flip puts it back. Same thing with the chlorine, it comes over to the left side, but the flipping it over sends it to the back. So now it's very easy to see that this is compound B that we have up here. So you can get to an enantiomer by just inverting all the chiral centers or by drawing the mirror image. So then the question becomes, if all four of these compounds are stereoisomers, and we have some pairs of enantiomers, what's the relationships between the non-pairs of enantiomers? For example, A and C. They're stereoisomers, but they're not mirror images, they're not superimposable. Same way B and D. So our other pairs we can consider A and C, A and D, B and C, and B and D. What's the relationship between these? Well, if we try to define them, they're pairs of non-superimposable non-mirror images. So these are different than enantiomers. Like enantiomers, they're non-superimposable, but unlike enantiomers, they're non-mirror images. These stereoisomers are given a different term. They're called diastereomers. In a pair of diastereomers that have chiral centers, one or more, but not all chiral centers are inverted. So in the pair of enantiomers, all the chiral centers get inverted. But in a pair of diastereomers like A and C, the chiral center with the chlorine stays the same. The chiral center with the OH gets inverted. So in diastereomers, one or more, but importantly not all chiral centers are inverted.